In this class, now I am going to explain you X-circles which are connected with a triangle. Now let us consider a triangle. Let us name of this triangle as ABC. Now extend AB side and extend AC side. On extending this AB and AC sides, here two exterior angles are formed. Now draw the exterior angle bisectors of these two exterior angles. So here this is one of the exterior angle bisector for this exterior angle, and draw exterior angle bisector of this angle and go to interior part of this triangle ABC and draw the interior angle bisector of A. Here what did I do? I have drawn the exterior angle bisectors for these two angles, and here I have drawn one interior angle bisector. These two are exterior angle bisectors and this is interior angle bisector. So these three are concurrent at one point. Let us name this point of concurrency is I1. Okay, right. Now if you measure the distance from this I1 to AB side and AC side and BC side, we will get the same. Okay, if you want, take compass and measure the distance from I1 to this BC and I1 to AC, I1 to AB. We will get same. Now take a radius from I1 to BC and draw one circle. So we will get one circle like this. This is called an X-circle which is formed opposite to vertex A. Okay. Now let us name whose radius be R1. R1 represents what here? Radius of X-circle which is formed opposite to vertex A and whose center is denoted by I1. Okay. Right. Now here I would like to derive a formula for this R1. For that, see, observe me what I am going to do here. Now area of triangle ABC. Area of triangle ABC can be expressed as area of triangle ABI1. ABI1 plus area of triangle ACI1. Area of triangle ACI1. Now what did I do here? Area of the triangle ABC is equal to, how I expressed, sum of the areas of this triangle and sum of the areas of this triangle. Sum of the areas of this triangle and this triangle. Okay. So from which I would like to subtract this triangle area minus area of triangle BCI1. BCI1. So observe carefully here. How do we get the area of this triangle ABC? To get the area of this triangle ABC, here what did I do? I have added these two triangle areas and from which I subtracted this triangle area. Okay. Now see, you know, here area of the triangle ABC is denoted by the letter delta. And you know the side which is opposite to vertex A, that is BC, is denoted by small a. Small a represents what here? Length of BC. The side which is opposite to vertex A is denoted by small c. The side which is opposite to vertex B is denoted by small b. You know this. Okay. Now write. Find the area of triangle ABI1. ABI1. So for this triangle, you know, this will be the base. 1 by 2 base. Base length is how much? AB equal to, we have taken C, no? C. Now write whose height area of a triangle? 1 by 2 base into height. That is fundamental formula, you know that. So here 1 by 2 base into height. So here ABI1, observe this ABI1 triangle, that is obtuse angle triangle. So for obtuse angle triangle, so you know we will get altitude outside of the triangle. Suppose if it is ABC triangle, if the obtuse angle is located at vertex B, so from the vertex A, you cannot able to draw the altitude inside. To draw an altitude from vertex A to BC, what we have to do? This BC has to be extended, and after extending this BC, we have to draw an altitude from A to this extension of BC. We will get outside. You know this. Okay? So in the same manner, here observe ABI1 triangle. So that is an obtuse angle triangle. So that for this triangle, we get an altitude outside of this triangle, that is R1 only. This will be the altitude for this triangle. But whereas for this triangle, it will be the radius. So similarly, draw the radius R1 from I1 to this AC side. So this will be the altitude for ACI1 triangle. ACI1. So here, this is also an obtuse angle triangle. So that while finding the area of this triangle, here R1 plus 1 by 2. So ACI1, area of triangle ACI1. So base will be AC. AC is nothing but B here. And radius will be R1. R1 only, no? Right. Now minus area of BCI1. So BCI1. So for this triangle, base will be the small a. And height will be R1. This will be the height. R1. Okay. And now simplify. Delta is equal to, from all of this, you can take R1 by 2 is the common. Inside what will be left? B plus C minus A. So in the next step, send this 2 to the left side. 2 delta equal to R1 into. So here I am adding 1 plus A, and at the same time I am subtracting minus A. Minus A will become minus 2A. Okay, here B plus A, added plus A, subtracted minus A. Minus A becomes minus 2A. So this can be written like this, you know. So now 2 delta is equal to R1. So here, as we know that, okay, S means what here? Semi-perimeter, A plus B plus C by 2. Now A plus B plus C by 2 equal to 2S minus 2A. Now take 2 common. Now 2 delta, 2R1 of S minus A. 2 cancel. Now this is equivalent to R1. Make R1 a subject. So R1 is equal to how much do we get? Delta by S minus A. R1 equal to how much, students? Delta by S minus A. Okay. So remember this. R1 equal to delta by S minus A. Here you know R1 represents a radius of this X circle which is opposite to vertex A. Delta means area of the triangle ABC. And S means semi-perimeter of this triangle ABC. Small a means length of BC. Okay? Right. Now let me explain you one more relation for this R1. I hope you have understood this derivation. Now let us go to one more relation. Right. Now see that. Let us consider this point be capital AX. Oh, sorry, X. This one will be capital Y. So here, this is one circle. Now for this circle, A is an exterior point. Am I right? So here we have circle and here we have one exterior point. From A, here we have drawn two tangents. One is AX and one more is AY. Both are tangents. As we know that tangents drawn from exterior point to the circle are equal in their length. Means AX equal to AY. Okay, now lengths of tangents drawn from exterior point to the circle are equal. So, see here students. Now, AX is equal to this AX summa. AX can be written here AB plus BX. Am I right? AX can be written AB plus BX. But here B is also an exterior point. So here AX, this is X we have taken, this is Y now, let it be Z. Now in this figure, B is also an exterior point. So here BX and BZ will be two tangents now, hence BX length will be equal to BZ. So now in the place of BX, what do you write students? AX is equal to AB plus BZ. AB plus BZ. Okay. Now you know AB length will be small c and AC length will be small b. Now in the place of AB write there small c. See students here. Okay, make BZ as subject. If you make BZ as subject, now AX minus AB you will get. Now BZ which is equal to AX will be how much? Don't know. Write as it is. Right. So AB length small c. Okay, keep it aside. So similarly, go to this side. Now here AY. Now AY can be written as AC plus CY. Now in the next step, AY which is equal to AC plus in the place of CY you can write CZ. Now make CZ as a subject. If you make CZ as subject, so here what do you get? Now CZ is equal to AY minus AC. AC is nothing but what? Small b. Now AY minus a small b. Okay students. Now add both of them. BZ plus CZ. BZ plus CZ. On adding BZ plus CZ, what do we get? Small a. Small a means what here? Length of the side opposite to vertex here, no? Here small a means which represents here length of BC. Okay? Right. See here small a which is equal to, see, add both BZ plus CZ. If you add both of them, so here what do you get RHS? Here BZ AX minus C and there AY minus B. Okay, these two I have added. So left side BZ plus CZ came and right side this plus this. Now in this figure BZ plus CZ is nothing but small a. And you know this AX and AY both lengths are equal, no? Lengths of tangents drawn from exterior point to the circle. Hence whose lengths will be equal? AX equal to AY. In place of these two, I can write 2 of AX. And from these two take minus common. Inside B plus C you will get. Now send this minus of B plus C to the left side. 2AX which is equal to A plus B plus C you will get. Now make AX as subject. Okay, otherwise 2AX which is equal to A plus B plus C is nothing but 2S. Now 2 cancel. AX is equal to S. So the length from A to X will be how much students? X here. Similarly A to Y also will be S only. S means what? The distance from A to S. Sorry, A to X. Suppose if you want only AB, how do you say AB length? Can I erase this? Right. See here. Suppose if you want this BX. Now BX can be written AX minus AB. Now, just now we learnt AX length we got S and AB length will be C. Now you know BX length is equal to BZ. Now BZ is equal to S minus C. The distance from B to Z is how much? S minus C. In the same manner, if you go to AY, whose length is S. Suppose if you want CY, S minus B you will get. That is equivalent to CZ. So CZ length will be how much, students? S minus B. S minus B. Okay? I hope you have understood how this CZ will become S minus B. Okay? Right. Remember here, BZ length will be how much? S minus C. CZ length will be how much? S minus B. So, hereafter, go to this triangle. Before going to that, take this AXI1 triangle. AXI1 triangle. From triangle AXI1. So you know this is A by 2 and this will be A by 2 because this is interior angle bisector. Now define tan A by 2 on this triangle AXI1. So go to here and define tan x by 2. With respect to this angle, this will be the opposite side. So R1 by adjacent side, whose length we got as S, no? Because here radius is perpendicular to the tangent at its point of contact. Hence, this AI will be the hypotenuse for this right angle triangle. So now I am defining tan A by 2. With respect to A by 2, this will be the opposite and this will be the adjacent. R1 by S. Now R1 is equal to how much, students? S tan A by 2. This is one more relation for R1. Okay. Now radius of this X circle also can be written as S tan A by 2. Okay. Now let us go to learn one more relation for this R1. So here, now I am considering triangle BZI1 in which, so students, see this complete angle measure will be how much? This is exterior angle. Exterior angle is equal to sum of two opposite interior angles. This total angle measurement will be angle A plus angle C. You know, you read in the plane geometry. Exterior angle is equivalent to sum of two opposite interior angle. Means this total measurement will be A plus C. But this is exterior angle, no? Hence, this length will be A plus C by 2. So this angle I1BZ will be how much? A plus C by 2. That is nothing but 90 minus B by 2. You know, sum of all interior angles of a triangle is 180 degrees. So here A plus C by 2 you want. So send B to the right side and divide with 2. So that you will get 90 minus B by 2. So this total angle will be how much? 90 minus B by 2. This is 90 minus B by 2. Whereas this one, this total measurement will be A plus B. Suppose if you want, however we have written this angle, in the same manner measure this length, you will get 90 minus C by 2. How much do you get, students? 90 minus C by 2. So in the next step, now I would like to define, so here, tan 90 minus B by 2 from BZ I1, from triangle BZ I1, define tan 90 minus B by 2. Okay, in BZ I1 triangle, right angle is formed at Z, no? Hence, this will be the hypotenuse. Now, with respect to this angle, this will be the opposite, this will be the adjacent. Now, R1 by S minus C. Now, tan 90 minus theta, cot theta, cot B by 2. Cot B by 2 equal to R1 into S minus C. Now, R1 is equal to how much? S minus C into cot B by 2. R1 means what, students? S minus C into cot B by 2. This is one more relation. Okay? In the same manner, go here and define tan 90 minus C by 2. Okay? Go there and define tan 90 minus C by 2. Tan 90 minus C by 2, which is equal to R1 by S minus B you will get. Now simplify. R1 is equal to, so S minus B into tan 90 minus theta cot C by 2. Okay. These are two more relations for R1. Now R1 is equal to S minus C cot B by 2. Here R1 equal to S minus B cot C by 2. Okay. Right. Now can I erase these two? Right. Now make S minus C as subject. On making S minus C as subject, what do you get here? So here I want to make S minus B and S minus C as subject. So here if you make S minus C as subject, R1 by cot B by 2 you will get. Now here S minus B, R1 by cot C by 2. Now add both of them, and adding both of them, what we people are going to get? So here add both of them on either side. So here S plus S, 2S minus B plus C. Now which is equal to, take R1 common from both of them. So here 1 by cot B by 2 plus 1 by cot C by 2 you will get. Now if you send both of them to the numerator, so we will get here A, 2S is nothing but A plus B plus C, and open this bracket, minus B minus C. Now if you send both of them to the numerator, so you will get tan B by 2 plus tan C by 2. Okay? Right. Now see, simplify this. So here minus B plus B cancel, minus C plus C cancel. Now small a is equal to R1 into, express these two in sin and cos. Tan B by 2 can be written sin B by 2 by cos B by 2. Here sin C by 2 by cos C by 2. Now take cross multiplication, so that what do you get? Small a is equal to R1 into, now take cross multiplication, sin B by 2 into cos C by 2 plus cos B by 2 into sin C by 2. Right. Now small a is equal to R1 into, so students here, what is left in the denominator? Cos B by 2 into cos C by 2. Here numerator is looking like expansion of sin A plus B. Sin A cos B plus cos A sin B. Hence it can be written as sin of A plus B. A means here B by 2. C means here, A plus B expansion. Sin A cos B plus cos A sin B. So that it can be written as sin of A plus B by 2. Here A means B by 2, B means C by 2. So finally you will get sin of B plus C by 2 by cos B by 2 cos C by 2. You know students, here b plus c can be written as b plus c by 2 can be written as 90 minus a by 2, because you know sum of all interior angles of a triangle is 180. A plus b plus c equal to 180. Now b plus c by 2 equal to 90 minus a by 2 you will get. Now a is equal to r1 into, so here what do you get? Sine of 90 minus a by 2. So here cos b by 2 into cos c by 2. Okay, right. Now simplify this. Now sin 90 minus a by 2 equal to cos a by 2. But this a I would like to write as 2r sin a. You know sin rule. By the sin rule a can be written as 2r sin a. Now r1 into cos a by 2 by this cos b by 2 into cos c by 2. Now here 2r, you know, express sin a in terms of submultiples, so that you will get 2 sin a by 2 cos a by 2, which is equal to r1 into cos a by 2 by cos b by 2 into cos c by 2. Now cos a by 2 cancel. Students, now bring both of them to the left side, so that here how much do you get for r1? 2 2s are 4. 4r sin a by 2 cos b by 2 cos c by 2. So this is one more relation for r1. 4r sin a by 2 into cos b by 2 cos c by 2. Okay, and now let us recall the formulas for this r1. I hope you have understood this derivation. Right. See, what is r1? Radius of X circle, which is formed opposite to vertex A. So which formula have we derived for r1 in the beginning? r1 equal to delta by s minus a. And one more formula we read for r1. What is that? r1 is equal to s tan a by 2. Similarly, r1 is equal to s minus b cot c by 2, and r1 equal to s minus c cot b by 2, and r1 equal to 4r sin a by 2 cos b by 2 cos c by 2. So this many formulas we have learnt in this class, along with whose proofs. Now r1 equal to delta by s minus a, r1 equal to s tan a by 2, r1 equal to s minus b cot c by 2, r1 equal to s minus c cot b by 2. So here r1 equal to 4r sin a by 2 cos b by 2 cos c by 2. Okay students. So what is r1? Radius of X circle, which is formed opposite to vertex A. Okay, opposite to vertex A means here A combination will not come here. B and C combination will come. Where B represents, you know, the side which is opposite to vertex B, means that is AC length. This is angle C. And here small c means AB length, which is opposite to vertex C. B means angle B. Here BC combination, here CB combination. Here R1 means radius of X circle opposite to vertex A, no? So here angle A, here before A by 2 sine ratio is getting, and for the remaining B by 2 C by 2 cosine ratios. Okay, for R1 here sine A by 2, remaining 2 will be in cos. Okay, here R1 delta by s minus a, R1 s tan a by 2. So R1 s minus b cot c by 2, s minus c cot b by 2, R1 equal to 4r sin a by 2 cos b by 2 cos c by 2. So here we have derived 5 formulas for this R1. Similarly, directly you can write R2 and R3 formulas. What is meant by R2? Radius of X circle which is formed opposite to vertex B. What is R3? Radius of X circle which is opposite to vertex C. Now let us write whose formulas. You know students here what is capital R? In previous classes you learnt. Okay, radius of X circumcircle. Okay, right. Now see, suppose if you extend this BA and BC, so this side we will get one X circle which is opposite to vertex B, whose radius is R2 and whose center is I2. Now let us write formulas for this R2, same like this. So R2, so if you derive okay, this R2 formula same like this. So firstly we will get delta by S minus B. Here delta by S minus A you got now. For R2 we will get delta by S minus B. And instead of this you can write R2 is equal to here S tan A by 2 no. Here S tan B by 2 you will get. And for this R2 is equal to here A and C combination will come. S minus A cot C by 2. And here S minus C cot A by 2 you will get. Now instead of this, what do you get for R2? R2 is equal to 4R. Here sin A by 2 no? Here cos A by 2 you will get. R2 means radius of X circle opposite to vertex B no? So here B will get sin of B by 2. Here cos C by 2. So these are the formulas for R2. Okay, delta by S minus B, S tan B by 2, S minus A cot C by 2, S minus C cot A by 2, and R2 is equal to 4R cos A by 2, sin B by 2, cos C by 2. Now let us write the formulas for R3. R3 means what? Radius of X circle which is formed opposite to vertex C. Now ABC. Now extend AC to CA to that side and sorry, this is B no, BC. Now CB to this side. Okay, here X circle we get outside to this ABC triangle opposite to vertex C. So whose radius is R3 and whose center will be I3. Now R3 can be written as delta by S minus C. Now R3 is equal to S tan C by 2. Now R3 is equal to, so A and B combination will come here. S minus A cot B by 2 and S minus B cot C by 2. Now R3 is equal to 4R here cos A by 2 into cos B by 2 into sin C by 2. Okay, I hope you have understood this. R1, R2, R3 formulas, and let me explain you two more relations between this R1, R2, R3. See here. Now if you multiply R, R1, R2, R3, what do we get to tell me? You know R1 delta by S. This is a derivation I have given in my previous classes. Now R1 delta by S minus A and R2 delta by S minus B. R3 delta by S minus C. Now write all of them here. Delta by S minus B, delta by S minus C. Okay. Now simplify here. Delta into delta, delta square. Delta into delta, delta square. By in the down, S into S minus A, S minus B, S minus C. You know students, Heron's formula. We use this formula to find the area of the triangle, which is derived by Heron's. Hence, on behalf of his name, we people are calling this formula as Heron's formula. You know what is S here? Semi-perimeter. Okay. Now if you take square on both sides, so what do you get here? Delta square is equal to S of S minus A, S minus B, S minus C. So now replace this by delta square. Now delta square cancel, delta square. Now R into R1 into R1 into R2 into R3 is equal to how much? Delta square. Remember this formula. Delta square is equal to R1, R2, R3. So this helps you while doing the applications from this solution to a triangle or properties of triangles. Okay. Now let us see one more relations between this R1, R2, R3. Now simplify this students. 1 by R1 plus 1 by R2 plus 1 by R3. So you know R1 is equal to delta by S minus A. When you take whose reciprocal? S minus A by delta you will get. And here S minus B by delta. Here S minus C by delta. Now, okay, denominator is delta. So in the numerator, so S plus S plus S, 3S minus A plus B plus C, which is equal to 3S minus 2S by delta. Now 3S minus 2S, S by delta. S by delta is nothing but 1 by R. Okay. Now remember this. Even this one also useful while doing the applications. 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay students. Thank you.